Well, hello and welcome to LSE Executive Education's webinar on large language models and the AI revolution. My name is James Thornton, and I work at LSE Executive Education as a Senior Marketing Manager. And today, I'm really delighted to be joined with Ken Benoit, who's the Director of the Data Science Institute at LSE, and he's a Professor of Computational Social Science in the Department of Methodology. And also Edgar Whitley, who is an Associate Professor of Information Systems in the Department of Management at LSE. Both teach our executive education course, Data Science for Executives, which focuses heavily on the webinar topic, plus many more. This course is going to be running at the end of October and in June 2024, and more information about this will be posted in the chat. In a moment, I'm going to hand over to Ken to kick things off, and then Edgar will follow, and we're going to have a short Q&A session at the end of the presentations. So please do post any questions you may have into the chat. We will have around 10 minutes for the questions, so my apologies in advance if yours isn't selected. And just to be aware that we are recording the webinar, and we will be sending this around to all attendees afterwards. For those of you just joining, welcome. And without further ado, I'd like to pass on to Ken, who will kick off. Over to you, Ken.
Thank you very much. So I'm going to be talking about large language models before Edgar. Passing over to Edgar is going to talk about some of the implications. And the idea is to give you a little bit of a taster of what we would be teaching in the course. And this is something that we completely changed the second half of this module this year to reflect things like ChatGPT and large language models and the power of transformers and generative AI and how that shapes the knowledge economy. This includes every aspect of the knowledge economy, the businesses, the organizations that our students come from, but also our own jobs. So I'm going to share my screen and use some slides for this. And let's get started. So let's talk about the importance of text as data. I don't really need to convince you of this, but the volume is just staggering because machine readable text is everywhere. These are just some basic statistics. I don't know what they're called now, X's or tweets, but they're about 8,000 sent per second. There are 66,000 plus Google searches in a second, and 2.7 emails sent in a second. These massive amounts of text are things that people are providing voluntarily, and they're things that are being recorded by businesses either as a byproduct of their activities or in some cases as a direct product of their business. We're also having problems with surveys, reaching people through asking them surveys because of fatigue and because of the decreased use of email, and also just people not wanting to take the time to complete the surveys is providing less and less information. This was one of the classic ways we elicited information from consumers, for example, or from customers or people, for example, taking our modules. If you take this module, you'll still get a survey, but we do a little text analysis as well. We also have increased computing power for processing large amounts of data, and this has transformed the types of analysis that we can do. So what is generative AI and what is deep learning? Well, many state-of-the-art generative AI models exist, but they are all built on top of deep learning. So I've got this concentric circle set here, which basically shows deep learning at the core. And deep learning is basically a subfield of machine learning, which involves deep layers of artificial neural networks. Artificial neural networks are something that we'd explore more in the course, but they consist of different nodes connected through different layers and different weights for the connections between layers, where it allows the incorporation of all sorts of knowledge, including the structure of language and the relationship of words to one another in context, which is what large language models are. And technologists, people doing data science engineers have been coming up with more clever and sophisticated ways over the years to figure out how to use these artificial neural networks combined with specialized graphical processing units and tensor processing units and libraries like PyTorch and TensorFlow that basically make this accessible to anyone with technical knowledge in data science. We have large language models running here at the Data Science Institute locally. We're also using them in the cloud. And of course, like everyone else, we are subscribers and users of ChatGPT. In fact, I used ChatGPT here to ask what deep learning was, and it basically explained that it's a subfield of machine learning that mimics the structure and function of the human brain. And this is a pretty good description. I'm not going to go through this except to impress upon you that there are a variety of different families of this type of artificial neural network called transformers. And transformers, you can see on the diagram on the side, consist of a type of encoding and decoding, and different transformers will use either an encoding model or a decoding model or some combination of the two. And if you were to look at this tree and its development, which follows also a timeline, you can see many that you'd recognize. So I'm sure you recognize ChatGPT. You might recognize Llama, the large language model released by Facebook. There's Bard. I just got an update notification about Bard yesterday from Google. Of course, there's GPT-4 now. Then there's some other ones that you may or may not have heard of, like Palm is a Google model, Bloom. There's some open source. Some of them are open source. So the ones that are shaded are open source, and the ones that are not are closed. Some of these you can download and use yourself. And then, of course, there's BERT and Roberta and the variety of models that are basically down here in this section, which are the ones that a lot of academic users are using. I've got one that I'm going to show you by the end of my brief talk that uses Roberta. Let's try an exercise. And this is one of the things we do in the executive course. We don't just talk at you and bombard you with PowerPoint. So we do a little bit of that, and then we get you involved. We do a lot of flipped learning. We do a lot of exercises. You will come to know your classmates, and you will be speaking and doing things in the course using computers, using the board, using exercises, and doing presentations. So let's try a game. You won't be able to do this in this format, but you can do this to yourself as a thought experiment. I'm going to show you some words on the screen. Your job is to have a look and write down another word, any word that first comes into your mind. Then you think about, why did you choose that word? So here goes. Data. All right, let's see what we might have come up with. Data privacy, data protection, data regulation, data security. These are the sort of words that Edgar is going to be talking about. I would have probably said right away, data science. Here's a sentence that we could complete, and this is actually how large language models work. There's basically a statistical foundation built on deep learning networks that completes the next word in a sequence. And by doing that in subsequent completions of words in sequence, it forms sentences and thoughts that mimic the structure of language, but also mimic the structure of our thought. Data science for executive course is the most blank. Think about that one for a minute. Well, while you think about that, let's talk about next token prediction. What happens when you ask ChatGPT a question? If you haven't used ChatGPT, if you took our module, you would definitely be using it. Next token prediction, this is the sort of answer you would get when you tell ChatGPT to explain next token prediction. It's basically predicting the next token, which is also a technical term for a word in a sequence based on the context of the preceding tokens. And it uses probability distributions to select these next tokens and determine what's the most likely one. And this sequence is called context. And different models have different size context windows. And one of the limitations of some of the models is that they have a fixed context window. And as we increase computing power and come up with more clever engineering methods to estimate words from context, we're able to increase this context window and make the models better and better. And this mechanism that I showed you the graph for is called, it's a mechanism called the transformer, usually with a capital T. It sounds like a Michael Bay film, but it's actually an established term in machine learning. So let's see how this works. So data science is the most, and then what? Well, we've got the tokens that are the context on the left. Then we have this mechanism, which is called an attention layer. And the attention layer maps the input tokens into what are called dynamic word embeddings. Since about 2014, we've had static word embeddings, which represent words as a vector of numbers that occur across dimensions, maybe hundreds of dimensions. And that is able to locate words within a semantic numerical context meaning so that we can figure out which words are related to one another because of their vector representations. Well, dynamic word embeddings use the context of the word to not just do this where one word has one vector across all usages possible in the language lexicon, but actually has a different vector representation according to the context in which it was found. And this enables us to predict things within sequence that have a much more contextually accurate meaning. This word embedding layer is a layer in a network that gets mapped into what's called a predictor. And this predictor produces a probability distribution over words that will be the most likely next word in the sequence. And in this example, the next token, as we can see in this probability distribution over here, where the longer horizontal bar represents a longer probability, the next word in the sequence would be popular. And then interesting, then possibly advanced. There would need to be another word. Data science is the most advanced, and then method for analyzing the social and political world could be a completion. Difficult might be a completion. There's a bit of dependence here. So if it chooses the word difficult, then the next completion is going, that context will have been added, and the next word that will be completed will need to make sense with difficult. But if it's popular, then the next word chosen will need to make sense with that. And by doing this in this really rapid way, you can see ChatGPT, if you type something in, you can actually see the words sort of appear one at a time. It's quick, but it appears one at a time across your screen. It's because it's doing this computation under the hood. So if we were to have taken the word popular, for example, then the next token would need to relate to popular. That could be topic or discipline or research. And because these things are trained on a huge amount of training data, the model can be very accurate. This is an example, a list of the training data sets in Facebook's Llama model. So there's something called the Common Crawl, which is a 3.3 terabyte data set of basically the entire web, where it's basically hoovered up web pages from everywhere. This is a well-known data set in web science and information retrieval that people use for demonstration. There's also something called C4, which is similar to Common Crawl. It's like a version of it that's smaller. GitHub, which is the biggest code repository in the world, owned now by Microsoft. They have access to all this code, which is why ChatGPT works great for programmers, because you can literally tell it what you want done, and it writes the function in whatever language you wish. Then, of course, there's things like Wikipedia. There's a book data set. Archive is the largest open paper archive for technical papers. And then there's this thing called Stack Exchange, which is the complete data set of questions that have been asked about programming, makes up about 2% of that. And if you add all this up, it's an absolutely massive amount of training data where all of the context of this has gone into training and learning these context-dependent word vectors that make up one of the important layers of the transformer models that can then be packaged into a predictive model so that it can take inputs in the form of text chats or API calls. So let me show you briefly what a typical session agenda would look like. And this is something that we do around day 4. We have a session about textual data. We talk about the methods for dealing with textual data. We talk about how to collect textual data from sources. We give examples of how to collect this from third-party data vendors. Then we talk about business applications that include things like spam filters, crime and fraud protection, how to manage risk and reputation, how to use this in business intelligence to analyze trends and the competitive landscape of the context of your organization, and how to better understand your customers and use that information for decision-making or improving innovation. And we would always follow this with each session with an exercise. We would tie the exercise to something that would be done in class. Sometimes we give exercises which are done with information that you'll need in the next session so that you get a chance to try out things before we actually cover that in our lessons. that it kind of cues up the need for that knowledge. And it also tells us what you know and don't know before we start teaching it. I'm going to end my brief presentation before I turn it over to Edgar with an example I'm working on at the moment. And I'm working on this with one of the third teacher who's not here because she's in Australia, Sabina Benoit, who's also my wife. She's a professor of marketing, and we are preparing a paper for the top journal in marketing science, Journal of Marketing. We have analyzed 95 million sentences from 21 million customer service reviews. Part of the data set we use is this Amazon customer reviews data set. It has 130 million reviews that we've only accessed a subset of. And this is something that we've all seen. I'm sure everyone has used Amazon. You might want to compare to different brands. You might want to look at the type of feedback that people are talking about. For example, are they talking about durability or appearance or price or the quality of the supplier and the experience they've had with customer service? Customer service reviews can come from any source, right? Not just Amazon. We've used Amazon for products and Yelp for services. They could also come from customer reviews from Google. And this is actually a pub, the George IV pub that is one of the favorites on the LSE campus, which if you came to take our module, you would come to know very well. And our example has been, it's an academic article, but it's actually packaged up into a web application called Review Pulse. And Review Pulse allows you to paste in a review, and then it breaks down each sentence of the review according to the aspect that was being discussed and the sentiment about that aspect. And it gives a breakdown. These are the aspects: product, price, place, people, promotion, processes, and physical evidence. In marketing, these are known as the 7 Ps, or the extended marketing mix. And if you put in the sentence from the Google review that we saw earlier, it would break this down. This good quality traditional pub, it's about service. These are probabilities on the right-hand side. It's also about location. And if we look at the sentiment, it's overwhelmingly positive. And there is something about differentiation as well that tells us that this is a distinct characteristic of this pub. And it does this for other sentences. If you would like to try this out, you can go to reviewpulse.app. And I don't know if you can see that, but if you click on that, I don't know if you can see it because I think I didn't share my whole screen, just the window. But if you click on that, you will be able to try it out yourself and paste in reviews. And if you want to send us feedback, you'd be welcome to hear it. I'm going to end there. I hope that was an interesting, very brief overview to an incredibly complicated topic with some applications. I'm going to turn it over to Edgar now.
Thank you very much, Ken, for that introduction to some of the technologies. What I want to do for a few minutes is just talk about some of the kind of ethical, legal, and also practical business management kinds of considerations that arise from using large language models for business. So first question, if you are using an LLM for business purposes, is, well, what data are you going to feed into your model that you are going to try and analyze? So the example that Ken gave is consumer reviews, and that's perfectly fine, ethically legal, because people write reviews precisely to give an opportunity to provide feedback to the service. In other cases, you might be using LLMs to analyze publicly available documents, official reports, official summaries of things. So in many cases, the data that you are analyzing has no particular ethical or legal issues, but at other times you have real challenges around, particularly if you're training up your model for a particular context, about what kinds of data should you be using. What are the ethical considerations that you need to put in place when considering the data that would feed into the predictions, the model that you are building up? Another part of that that kind of was illustrated nicely with Ken's game was, if you have got a large language model that is making predictions about how that sentence is going to continue, you also have a whole series of next words, next statements, next sentences that are incredibly unlikely to be there. Now, statistically, that is absolutely fine. But what happens if one of the frequently mentioned but not particularly desirable for your business next phrases is something that you really don't want your product to be associated with? And what we see, even in things like ChatGPT, is that there's actually an awful lot of work going on behind the scenes to kind of control the extent of what next predictive phrases are actually coming along. So when Ken put his thing about data science courses, the course is it's unlikely to be hungry. But that's very straightforward. That's statistically unlikely. But what happens if your customers are providing text that is more contentious? We're already seeing situations where large language models are being asked about more sensitive topics. There was a recent news story about people using these tools to ask for questions about anorexia, which becomes much more of a challenging environment. And if you are using these tools in an open, unconstrained situation, the last thing you want is for your LLM, your AI system, to start giving answers about topics that you really don't want to have associated with your brand. So you have a real challenge there. The other thing that's I find really fascinating about ChatGPT, and this comes to the broader question about how AI is going to transform the nature of work, comes back to the question of, well, what are you generating text for? What are you using text for? There's always the possibility that you are using it to generate text that has limited use, limited benefit for society. So that you may have seen the kind of the meme online of someone going, this AI is really, really great. I can take a one sentence idea and convert it into a 3-paragraph email that I'll send to my boss. And then you see the other side of that, which is the boss going, AI is really great. I can take this 3-paragraph email and convert it back into a single sentence. So there's a real question, I think, here about what kinds of business processes you actually want your AI to help with. And it's great to just say, oh, we're using AI, we're using large language models, but miss the point about how the business value can actually be added. And that's one of the things that we engage with on the course, is how to use these different forms of technologies, large language models, etc., for achieving particular business opportunities. You also need to bear in mind, particularly from a business perspective, about how your requirements, how your language is changing and evolving over time. So in some cases, the language, the terms, the phenomena don't need to be that much updated. If you've got the right kind of text in your set of text that you trained your model on, then that's absolutely fine. But sometimes you may want to have an evolving model that picks up on the latest conversational trends and can make sense of them, rather than just goes, oh, that's bad. So Ken gave the example of the restaurant or the pub review. If you were a trendy young person, you may say that's a really sick place, meaning it's a really cool place. But if your large language model hasn't evolved to take sick as being either a negative sentiment, or possibly a really positive sentiment, then you run the risk of making ill-informed decisions based on inaccurate rendering of the data that you have. So really, you need to think very carefully about how the technology works, how you are going to use the technology in your business application, and what some of those questions that arise around the ethics or the legality of the use of AI, as well as how it's going to integrate with your existing processes and your existing interactions. And I think at this point, I will pause and we'll see if there are any questions and answers for Ken or myself.
I was just answering one or two from the Q&A. I can take another one from Sebastian. First question is this course online or on-site in London? It is on-site in London, and that's one of the wonderful things about the course. You have access to the amazing physical facilities of the LSE and also to us personally, and there's a great interactive element in meeting your fellow course participants. So we have reception, we have a nice dinner, and there's a lot of social networking, in-person social networking, not online, that takes place throughout the course. Another question, in your opinion, are the EU and other Western institutions effectively regulating AI, and where could they improve? It's one for Edgar, I believe.
Yeah, so obviously at the moment, everybody is talking about regulating AI. There's not, I mean, there are EU-wide proposals, there's discussions in the United States about regulating. I can understand why the regulators want to regulate, but there's still the question of, well, what kinds of regulation? What are the problems that you are wanting to address? So we have another question about, are there practical ways to avoid training data perpetuating biases in society? If we take those two together, to what extent is the choice of training data going to feed into societal concerns about bias, and then how do you actually regulate that? Would it make sense for a government to say you must now include these alternative data sources as a way of making sure that your AI model doesn't have the biases or tries to minimize the impacts of the biases? A related question is, are those strict regulations hinder AI regulation? That is a big political question that all governments around the world are really addressing. If you are concerned about the effects that AI has on society, then regulation becomes one of the ways to limit those negative unintended consequences. But if you overly specify and too tightly regulate up front, then you run a real risk of stifling the innovation opportunities, because you cannot predict what's going to be really successful in a year's time, in 3 years' time, in 5 years' time. So there's a kind of regulator's dilemma. Don't over-regulate up front, but equally don't create a Wild West scenario where data issues and AI applications run wild and cause irreparable harm to society, whether it's through bias or whatever.
The last part of that question was also, do we know of any studies that have questioned the degree to which ChatGPT is biased, or in what areas it's biased? And the answer to that is yes. There are a number of really interesting papers that have emerged that look at some of the biases of large language models. One of the problems of models that are trained on so much data that's out there, basically you build a model based on scooping up all of the internet. What could possibly go wrong, right? This is actually a deep concern, because the world that existed that we train the models on is not really the world that we wish to exist. We don't want these models to perpetuate the biases. There are a lot of efforts to mitigate that. There's something called reinforcement learning from human feedback, or RLHF. That is part of the process whereby humans will score the quality of the answers, and especially in sensitive areas, they can even mark areas as being sensitive. So that's why if you use ChatGPT to try to get it to make sexist comments or racist comments or political comments, it will simply say, I won't talk about that. Of course, there are ways to trick it. There is a paper I read recently that showed that when answering political surveys, that ChatGPT was slightly was more leftist than rightist in terms of political orientation. So there is a lot of work being done on that. Someone also asked, and I think I answered this in the chat, do you need any data science background or technical background in order to profit from this course? The answer is absolutely not. The way that we teach the module is such that it requires no prior knowledge of data science. In fact, what we value is people who have a need to learn data science and who are working in organizations where data science is required, or maybe there's a team already using data science. We give you the tools that you need to understand what that team is talking about and to join that conversation and possibly to manage and make decisions based on the information coming from the data scientist in your organization. We are not training you to become a data scientist.
So there's a question from Zachariah. Why has or does regulation historically lag behind technological developments? A personal kind of biased view on this is that very often the regulators don't necessarily know that much about the technology. They think it's this big shiny thing that's going to transform the world immediately without having a real appreciation, A, of how the technology works, and B, just the straightforward, boring system business practices about how you are going to integrate your existing workflow processes to interact with a large language model or some other data science or AI kind of model. Because there's an awful lot of relatively unsexy plumbing that needs to be done to integrate the various services that are available. Plus, of course, you need to go out and procure that service. So do you just go to ChatGPT because that's the one that you've heard about, or do you go with your existing provider? How do you assess the capabilities of the different tools that are available? Just make a decision about which one is most appropriate for your organizational needs, your organizational context.
Let's take another course. There's a couple of questions. Actually, there's one from Russell about does the course cover the dangers of model collapse? And a related question, which is from an anonymous attendee who asks whether it's true that ChatGPT has gotten dumber in recent months due to more popular use. First of all, for the proprietary models, like the ones from OpenAI, which is ChatGPT and GPT-4, there are different versions, but they're also constantly refining those models based on usage and additional information and additional reinforcement learning from human feedback. Whether they're getting dumber or not is something that there are academic researchers trying to gauge this using tests, but it's very difficult to know for the proprietary models. No company is going to admit that their product is getting worse rather than better. By most benchmarks, they are all getting better. So I think we're just going to see continuous improvements in the quality and sophistication of these models, the speed at which they're developed, and the domains in which they're applicable. So GPT stands for Generalized Pre-trained Transformer Model, and that generative, sorry, it's difficult when you're doing these things live. This pre-training is done on a specific set of texts that are necessarily general, but they can be fine-tuned for domain adaptation using specifically legal language or political language. And a lot of people have adapted them for specific tasks rather than the sources that I showed you briefly. And as they get more adapted to specific domains, they become smarter in that context. So I wouldn't think that they're getting dumber. This notion of model collapse, though, there's a really interesting paper written by a huge set of co-authors that basically predicts the problem of model collapse when, if we use ChatGPT to generate all knowledge for the next 20 years, and then we train ChatGPT on the knowledge that we publish based on the knowledge that it generates, we're in this feedback loop where there's no original knowledge being generated of the sort that was part of the training for, up all of human history up until the advent of ChatGPT, then knowledge becomes all derivative. And this is a general philosophical and practical problem that we'll have to address as a society and technologists. But it's not something that I would think we're at risk of for the next couple of years.
I think to some extent that varies a little bit from domain to domain. So absolutely, in terms of general knowledge, there's enough academics who still have jobs creating research based on their own thinking rather than ChatGPT generated text. But in other areas, we're already starting to see the kind of, the models have ingested everything that is available. And then you get to interesting questions about how you incentivize people to contribute new knowledge in an area as new problems emerge. And the classic example of this is the kind of Stack Overflow programmer help, where it's ingested all of the questions and all of the answers to common programming problems, so that you can now get ChatGPT to really help you with pretty much any of the mainstream tasks in programming. And then the question comes, well, if ChatGPT can't help, why would I go to something that might now just be running ChatGPT answers anyway? So there's a potential risk about our knowledge in particular subsets of expertise becoming relatively finite, and with no incentive for people to contribute to that common good particular situation.
I'm a frequent user and question answerer on Stack Overflow, and they broadcast these policies, and one of their policies is they prohibited answers that are actually generated from ChatGPT. They don't want people trying to get points and credit for answering questions using the same thing that they want original content to train the equivalent of ChatGPT for. So there you would get a direct feedback loop.
So we've got one interesting question. Does AI differ between Chinese and English speaking language, since the language will change the algorithm outputs? Absolutely. I mean, from the slides that Ken showed, the predictions about what are the next phrases will definitely vary from language to language. Informal kind of experimentation with colleagues shows that even the kind of generic ChatGPT is increasingly being trained on a wide variety of languages. What becomes particularly interesting, however, is if you don't take English or Chinese or Spanish as languages that are spoken by large proportions of people, but choose a more specialist niche. And the example that came up with Danish. So Denmark is a relatively small country, doesn't have a global footprint of Danish speakers in other parts of the world. So how do you go about building your models if you want it to be particularly well trained on texts from the Danish language? Because by definition, that set of data will be much smaller. There's a question from Martin: which industry sectors will most benefit from AI in the next 5 years? If I knew that, I would be investing heavily in those particular sectors. I suspect that it will really be driven by an understanding of how the technology can help particular industries. So if we're talking about large language models, we're talking about industries that particularly rely on text-based interactions, such as the reviews that Ken gave in his example. If you are a manufacturing organization, then the amount of language-based resource that you are using is probably more limited. But there are other AI models and other data science models that we also cover in the course that can be incredibly useful for those non-language based activities, spotting a production process where the outputs are suddenly very dissimilar to what you would normally expect. So it's, when you talk about which sectors will benefit from AI, as the academic, I would say, what kind of AI are you talking about? Because different sectors will benefit in different kinds of ways. think we've got
We
time.
have a question about someone asked, I'm interested in more technical and development focused content. Do we offer such courses? The answer is not in the executive program. It would be very difficult to cover that for a heterogeneous professional audience in 5 days. However, there is a summer school course and summer school track in the program on data science and statistics. I'm currently the program director for that, and I also teach a large course called Introduction to Data Science and Machine Learning. So if you wanted to do a 3-week deep dive into actually programming in R and SQL and doing fitting machine learning models and interpreting them and learning some of the mathematics behind them, that would be the course you'd want to take. And we do have more advanced versions as well. There's a follow-on course to that, and a few more specific ones in machine learning, but that wouldn't be part of the executive program. I think we might have time for one more. Martin asks, which industry sectors will benefit most from AI in the next 5 years? The short answer is all of them. And a more specific one is the knowledge economy will both benefit from and be transformed and challenged by, because we're having to change the way we do things. It's an interesting one because technological change in the past and previous industrial revolutions have come for manual laborers' jobs. This is the first time that it's coming for intellectual laborers' jobs, including possibly our jobs. So we're having to adapt as educators, for example, in ways to make our content and our participation meaningful and differentiate ourselves from what ChatGPT could be teaching you.
I'm going to step in and say to Edgar and Ken, thank you so much for sharing your insights in this session today. And also thank you for all the questions that have been submitted. It's been a really fascinating discussion. If you would like to know more about our courses, obviously, as we've mentioned, we have our executive education program in data science for science for executives, running on the 30th of October. That's a 5-day program. It'll also be running again on the 3rd of June in 2024. There's also an online course that Ken runs, data science text analysis using R. And we'd also really encourage you to check out the insights that come out of the LSE Data Science Institute for all data science AI content that's coming out of LSE. We will be sending this information around via email, and we'll also be sharing the recording of this today's session, so you can rewatch at leisure. But once again, thank you for your attendance today. Thank you to Ken and Edgar, and hope you enjoy the rest of your day. Goodbye.
Thank you.